Beryl, Beryl, Beryl is my school, best education reservoir for young learners just like me. Beryl, Beryl.
Hello, students of Beryl International School, and welcome once again to another phase of Beryl e-learning. Today we're looking at mensuration. Mensuration is a very broad topic. So we're just looking at length of arcs, areas of sectors, and this time we also look at perimeters of sectors. So we're not waste our time looking at area aspect of mensuration. You know what mensuration is all about, the process of measuring and calculating the length, areas, and volumes of all geometric shapes we refer to as mensuration. So like I said earlier, we're looking at length of arcs, areas of sectors, and perimeters of sectors. Before we go into that, we ask, what is an arc? An arc is referred to as any curved part of a circle. An arc is referred to as any curved part of a circle. So, the length of an arc is given by the formula theta all over 360 times 2 pi r. Theta all over 360 times 2 pi r. Theta is the angle subtended at the center of the circle. All over 360, the angle that makes up the circle, times the circumference of the circle, 2 pi r. Theta is the angle subtended at the center of the circle. All over 360, the angle that the circle makes, then times the circumference, which is 2 pi r. That gives us the formula for finding the length of an arc. So look at a question. An arc subtends an angle of 105 degrees. At the center of radius 6 cm. Find the length. Find the length of the arc. If pi is 22/7. An arc subtends an angle of 105 degrees at the center of the circle of radius 6 cm. We have to find the length of the arc if our pi is 22/7. We can first begin by drawing the circle. This is a circle with our center. We can call it O. We are told that this arc is a curved part of the circle. So this is our center O. And any straight line that starts from the center of the circle to a part of the circumference is called radius. So our radius is 6 cm. So this line gives us the radius, and there is also 6 cm. The angle subtended at the center is 105 degrees. So the angle we have here is 105 degrees. Now our pi is 22/7. Having made this sketch, how do we find our length of arc? We apply this formula. Remember, we said our theta is 105 degrees. So we say 105, that's our length of arc. We can call it L. 105 all over 360. Then times the circumference. I said the circumference of the circle, which is the distance around the circle, is given by 2 pi r times 2 times our pi, which is 22/7, then times radius 6 cm. Okay, from here we can cancel out. So let's say 6 into itself is 1, 6 into 360 will give us 60. From there, 7 into itself is 1, 7 to 105 will give us 15. We can choose to write out the remaining values we have. We have 15. Our length L equals 15 times 2 times 22 times 2 times 22 all over 60. Okay? 15 to itself is 1, 15 to 60 is 4. What we have left is 2 times 22 times 4. 2 times 22 give you 44. 44 over 4. 4 into 44 is 11 cm. So the length of the arc is given as 11 cm. Can we just summarize? We are told that the length of an arc of a circle is given by the formula theta, all over 360 times 2 pi r, which is the circumference of the circle. And we say that theta is the angle subtended at the center of the circle, and 360 is the angle that forms the circle. Then times the circumference is 2 pi r. Now, from our sketch, this is our angle theta. We say, in place of theta, we have 105 all over 360 times 2 times pi, 22 over 7 times our radius, which is 6 cm. 6 into itself is 1. 6 into 36 is 6. Into 0 we have 0. 7 into itself is 1. 7 to 10 is 1 remainder 3. Into 35 is 5. What do we have left? 15 times 2 times 22. 15 times 2 times 22. All over 60. 60 times 1 is give us 60. 15 into itself is 1. 15 into 60 is 4. 2 times 22 over 4 is what we have left. 2 times 22 is 44. 44 over 4. 4 into 4 is 1. 4 into 4 again is 1. So we have 11 cm. That gives us the length of the arc of that circle, having angle 105 degrees and radius 6 cm. Alright, we saw another example. Okay, we're looking at a case where an angle is given. So the length of the arc is given, and now to find the angle. What angle does an arc 6.6 cm in length subtend at the center of a circle of radius 14 cm? Use pi equals 22 over 7. In the first example we saw, we have to find the length of the arc given an angle. At this point, we are not given the angle. We are only given the length of the arc, which is 6.6 cm, the radius of 14 cm, pi at 22 over 7, but the angle is not given. How do we find the angle? We still maintain our formula, length of an arc as theta over 360 times 2 pi r. In place of our length, we use 6.6 cm. What angle does an arc of length? 6.6 cm in length. So we say 6.6 cm equals theta. The angle is not given, remember. So in place of theta, we still write it as theta. Theta over 360 times 2 times our pi, which is 22 over 7, then times our radius, which is 14 cm. Then from here, we have theta over 360 times 2 times 22 over 7 times 14 cm. We can just simplify by cancelling. 7 into itself is 1, 7 into 14, we have 2. Okay? We can now choose to cross multiply. Cross multiply. We have 6.6 cm times 360 equals theta. Theta times 2 times 22, theta times 2 times 22 times 2. By cross multiplying this divided by 1. 6.6 cm times 360, we have it here. Then equals 1 times all of this is giving what we have here. Theta, which is here, times 2, which is here, times 22, then times 2. So from here, what do we do? We are going to find theta. We say 6.6 cm times 360 equals theta times 2 times 22 will give you 44. 44 times 2 will give you 88. So we have theta times 88. Remember that theta times 88 will give you 88 theta. For us to find theta, we divide both sides. Divide both sides by 88. This will give us 6.6 cm times 360 all over 88 equals theta times 88 all over 88. Of course, it takes down itself and we're left with theta here. So, at this time we divide 4 into, or that is 11. 11 into 88 will give you 8. 11 into 6.6 will give you 0.6. So what we have left is 0.6 times 360 over 8 equals theta. Theta is left here. 0.6 times 360 over 8. Now, 8 into itself is 1. If you divide 360 by 8, that should give you 45. 360 divided by 8 should give you 45. Good. So I think it's 45. What we have left is 0.6 times 45. If you calculate that, 0.6 times 45 should be equal to 27. So the angle subtended at the center of that circle, given a length of 6.6 cm, is 27 degrees. What angle does an arc 6.6 cm in length obtained at the center of a circle of radius 14 cm using pi as 22/7? We first write our formula. Length of an arc is given as theta over 360 times 2 pi r. Now, in this case, like I said, the angle is not given. What we're doing is the length of the arc, the radius of the circle, and the value for pi, which we already know. Now, theta over 360 times 2 pi r. Length is 6.6 cm on the board equals theta, which is not given, all over 360 times 2 times 22/7, then times our radius of 14 cm. At this point, we cross multiply. This multiplies everything here, while this multiplies. Before we multiply, we cancel out 7 to itself is 1, 7 to 14 is 2. Then we say 6.6 cm times 360, and we have here equals theta times 2 times 22 times 2. Theta times 2 times 22 times 2. If you multiply all these, 2 times 22 is 44, times 2 is 88. So we have theta times 88 equals 6.6 cm times 360. Since we have to find theta, we divide both sides by 88. So 88 cancels itself, we have theta left. 11 to 88 is 8. 11 to 6.6 is 0.6. We have 0.6 times 360 all over 8. 8 into itself is 1. 8 into 360 is 45. Okay, we are done with the length of arcs of the circle. The next we're looking at that. So I said told us that we're looking at the area of a sector. So the question we have on the board has to do with the area of a sector. Now, what is a sector? Like you were taught in your junior secondary, we say that the sector of a circle is any fractional part of a circle and is bounded by an arc and two radii. We have a circle on the board. We have these are the center of a circle. These are two radii. Radii is the plural form of radius. So we have two radii and we have an arc, meaning that this region is called a sector. This region is called a sector. The sector of a circle is a fractional part of a circle that is bounded by an arc and two radii. So this is a sector. On the other hand, this other part is a sector. We call it a minor sector, but I won't go into explaining that. So that is a sector. You have to calculate the area of a sector of a circle, which is obtain an angle of 45 degrees at the center of the circle of radius 14 cm. Like I said, our circle with center O. The radius here is 14 cm. And the angle subtended at the center is 45 degrees. We have to calculate the area. The area of sector. The formula of finding area of sector is theta over 360 times pi r squared. For length of arc, we say theta over 360 times 2 pi r, meaning theta, that's the angles of 10 all over 360 times the circumference of the sector for length of arc. While for area of the sector, we have theta over 360 times the area of the circle times the area of the circle. For area of sector, we say the angle all over 360 times the area of the circle. But for length of arc, we divide the angle by 360 times the circumference of the circle. Now, looking at this question, our angle theta is given as 45 degrees. This is the symbol for area of sector. Equals theta is 45 degrees all over 360 times pi. Our pi is 22 over 7 times our radius is 14 cm times 14 cm. R square means R times R. So we say 14 cm times 14 cm. Now we can cancel out. 7 to itself is 1. 7 to 14 is 2. 45 to itself is 1. 45 into 360 is 8. Yes, 8 times. So what we have left? We have 22 times 14 cm times 2 cm. Then all over 8 times 1. 1 times 22 times 14, then times 2. All over 8 times 1. From here, we can choose to cancel this 2 cm. 2 here is 1, 2 into 8 is 4. 2 into 4 is 2, 2 into 22 is 11. So we can choose to write it out before we further simplify. We have 11, area of sector equals 11 times 14 cm times, this is 1, times 1 cm all over 2. 2 times 1 is 2, all over 2. 2 into itself is 1, 2 into 14 is 7. All we now have left is 7 times 7 cm times 1 cm. 1 or 11. Okay, we have 14 here. 11 times 14, okay. We have 11 times 7, sorry. I skipped 11. 11 times 7, then times 1. 11 times 7 is 77, and 77 times 1 will give us 77 cm squared. So that is not the area of sector of that circle. For area, you must carry power 2. For area, you must carry power 2. When we were doing the length of arc, there was no power attached to it. You don't have cm, give the length of arc. For areas, we must attach power 2 to it. Calculate the area of the sector of a circle which obtains an angle of 45 degrees at the center of the circle, radius 14 cm. We have sketched the circle and attached an angle of 45 degrees, and the radius is 14 cm. Remember, we said the radius is a straight line from the center of the circle to any part of the circumference. So this is 14 cm, and this is also 14 cm. Now the formula. Area of the sector is given as theta over 360 times area of a circle pi r squared. And our pi is given as 22 all over 7. Whether it is given in the question or not, take note that the value of pi is given as 22 over 7. In some other cases, you can be given other values for pi like 3.142, 3.14, and so on and so forth. Now, our theta is 45, then all over 360 times our pi, 22 over 7, times r squared, meaning r times r. Our radius is 14 cm, so we have 14 cm times 14 cm. We now cancel out. 45 to itself is 1, into 360 we have 8. 7 to itself is 1, into 14 we have 2. Now what is left? We have 22 times 14 cm times 2 cm. Then all over 8 times 1. We further simplify. 2 into 8 is 4, 2 into 2 is 1. Then 2 into 4 is 2, 2 into 22 is 11. What we have there? 11 times 14 cm times 1 cm. 11 times 14 cm times 1 cm. Then 2 times 1, we have 2. From here, 11 times 7 cm times 1 cm. 11 times 7 is 77. 77 times 1 is still 77. So the area of the sector of our circle is given as 77 cm squared. Alright. Okay. Let's look at this other example. The sector of the circle has an area of 55 cm squared. If the radius of the circle is 10 cm, calculate the angle of the sector. At this point, we are given the area of the sector and we have to find the angle subtended at the center of that sector. So, the formula still remains the same. We can decide to make a sketch for a better illustration. This is our circle, and the area of the sector is 55 cm squared. The radius is 10 cm. This is our center O. The radius is 10 cm, and the angle is not given. We can just write theta. How do we find the angle? We first write out the formula. The area of sector is given as theta over 360 times pi r squared. Like I said, the sector of a circle has an area of 55 cm squared. 55 cm squared is the area of sector. So in place of area of sector, we write 55 cm squared equals theta, which is not given. We can calculate the angle of the sector. Theta is called the angle of the sector. The angle of the sector. So we say theta over 360 times pi, 22 over 7 times r. Our radius, if the radius of the circle is 10 cm. So we say 10 cm times 10 cm. Like I said before, r squared means r times r, so we have 10 cm times 10 cm. 0 cancel 0. What do we have left? Okay, we can choose to cross multiply from here. We cross multiply. We have 55 cm squared times 36 now, which is left, equals theta times 22 times 10. 10 times 1 is 10. So we have 55 times 36 equals theta times 22 times 10. Since we are looking for theta, we can say 55 cm squared times 36 equals theta times 22 times 10 equals 220. For us to find theta, we now divide through by 220. So we have 55 times 36 over 220 equals theta times 220 all over 220. 220 will cancel, 220 we have theta left. What we now have is our theta is giving us 55 times 36 all over 220. 11 to 55 is 5. 11 to 22 first is 2. 0 is 0. So, what we have left is 5 times 36 all over 20. 5 into itself is 1, 5 into 20 is 4. We have 36 over 4, which is 9. Our theta is equal to 9. Our theta is equal to 9. Let us go through it again. I think we missed 7 here. Okay, area of the sector is given as theta over 360 times pi r squared. When we cross multiply, we have 55 times 360 times 7. We missed it. Sorry. Okay. From here, after simplifying, when we cross multiply 55 times 36 times 7, I didn't see 7. So times 7 equals theta times 22 times 10. 55 times 36 times 7. 36 and plus 0 has cancelled 0 already. We have 55 times 36 times 7 equals theta times 22 times 10. At this point, we say 55 times 36 times 7 equals theta times 220, that means 2 times 10. We now divide by 220. 55 times over 220 equals, this time you can write it as 220 theta, then all over 220. This you cancel this, you have theta left. This theta we have it left equals 55 times 36 times 7 all over 220. At this point, 11 to 55 we have 5, 11 to 22 we have 2, into 0 we have 0. What is left? 5 times 36 times 7 over 20. 5 here is 1, 5 here is 4. 4 into 7 is 1, 4 into 36 is 9. So our theta is 9 times 7 equals 63 degrees. So the angle subtended, the angle of the sector of that circle is 63 degrees. So our theta here is 63 degrees. Let me summarize it again. The sector of the circle has an area of 55 cm squared. If the radius of the circle is 10 cm, calculate the angle of the sector, where our pi is 22 over 7. We make our sketch, this is our angle of sector, theta which is not given, and our radius, or radii rather, 10 cm each. Okay, now these are formulas on the board, we apply the formula. The area of the sector is given as 55 cm squared equals theta, which is not given, all over 360 times pi, 22 over 7, times r squared, which is r times r, 10 cm times 10 cm. Okay, now 0 will cancel 0. What we have left is 36 here. We cross multiply. 55 times 36 times 7. 55 times 36 times 7 equals theta times 22 times 10. Theta times 22 times 10. Now, 55, we have this here. 22 times 10 is 220. We now have theta times 220. For us to get our theta, we divide both sides by 220. Now, this all over 220 equals 220 theta all over 220. 220 will cancel itself, we have theta left. Now, equals 55 times 36 times 7, then all over 220. We divide by 11. 11 to 55 is 5. Into 22 we have 2, 0 we have 0. Okay? 5 is left, 5 times 36 times 7. 5 times 36 times 7, all over 20. 5 into itself is 1. 5 into 20 is 4. 4 into itself is 1. 4 into 36 is 9. 1 times 9 is 9. 9 times 7 is 3. That gives us the angle of the sector of that circle. I think we'll stop here for today, but I'll give you one assignment to do and submit. Okay, this will form your assignment. The arc of a circle of radius 20 cm subtends an angle of 120 degrees at the center. Use the value 3.142 for pi to calculate the area of the sector correct to the nearest cm squared. The ones we solve, we use 22 over 7 for pi, but for this, in solving, you have to follow this motion, use 3.142 to find as your pi, and then calculate your area of sector. Number 2, an arc subtends an angle of 75 degrees at the center of the circle of radius 12 cm, and to find the length of the arc using pi as 22 over 7. For each of them, please make sketches, draw your diagrams, and you get your angle theta and your radii. This will come to the end of this section of the Learning Mathematics class for SS3 students. We'll stop here for today. Do your assignment and submit next week. See you next week. Goodbye.